Yes.
Okay, please everybody mute your mic. So the last 10 minutes again, we are going to have questions. Okay, in the first part, we discussed the overview of the rig systems in a very short brief about the circulating system and bits and rotating systems and stuff like that. So for this part, I'm going to go through the drilling bits in here. So in general, it's the drilling engineer's responsibility in office. In each company, it's the drilling engineer's responsibility to select the best bit. The best bit means the most durable bit. That means the any bit which can last for a longer time. That's the best bit. This is first thing. Second thing, it's not only about a bit which can stand or last for a long period of time. It should also perform in a desired way. That means your ROP or rate of penetration must be reasonable or in line with the plan, and also the bit must last in the hole for a long time. So you have two criteria to select any bit as drilling engineer. Hopefully in the future, you will become a drilling engineer in any oil company. So that's going to be your responsibility. Any bit which can last for a long period of time, the longer the better, and also it has to have a reasonable ROP, rate of penetration. The bit can stay in the hole for 10 days, doesn't mean that's the best bit if it cannot drill like what you want. Okay, so this, according to the mainly the formation specification, you select any bit, and like I said, it depends. Any well cut or any exploration well, you don't have much information about the formations, the geological formation, what kind of issues you are going to face. So, but if based on the previous performance by each bit, each manufacturer of the bit, you select your best bit. Main thing in selecting any drilling bit is the harder formation. You need a shorter teeth or the cutters on the bit in here. Okay, so the harder formation you are predicting, the shorter teeth or the shorter of length of the teeth you need to select. And like I said, tripping is expensive. Anytime if you run in hole and pull out, for example, if you drill in the HCAN wells in the 6-inch hole, it takes at least 24 hours. Okay, 24 hours to come out of the hole and get back to the same point. So 24 hours, if you convert to the cost, it's probably 5% or sometimes 10% of your entire budget. Well, so any tripping, any pulling out and running hole is very costly. And especially if that's just because of the bit cannot drill any further, then you have to pull out. That's one of the issues you need to work on as a drilling engineer to improve your bit selection. So the less bit you use, the better for you, because you are going to get rid of a lot of trips. So this is why we are focusing on a long period of time and also the ROP. So we have several types of bits, as you see in here. We have the tri-con bits. This is the tri-con bits. Tri means three, so it has 3 cons. So that's why they call them tri-con bits, or sometimes they call them rotary bits or rock bits and stuff like that. So you have the size of these bits up to 48-inch to 4 3/4 inch size, but usually 4 3/4 is not used for drilling. The smallest size we are using for drilling is the 6-inch hole, 6-inch bit for the 6-inch hole. And also we have the PDC bits, tungsten carbide bits. That's the abbreviation of PDC. This type, if you see the mouse cursor, this is the PDC bit. Okay, this is more aggressive with if you have the top drive. So nowadays, for example, in HKN, we are using much higher RRP compared to the track-on bits. And also we have the diamond bits. These diamond bits are very, very rarely used in the oil industry. And I've never heard any company worldwide have used diamond bits for oil wells. I think sometimes they are using it for geothermal wells and some other purposes. So it's very rare. I've never seen it in my life. But PDC is very common with the track-on bits. If you take HKN as an example, we are using drilling PDC bits for drilling for all the sections because they have performed the best PDC bits, but with a lot of specifications and features that we require. Nowadays, we have drilled probably, I don't know exactly, about 7 wells. So any well we drill after 7 wells, you have huge information and you have a huge data about the formations and the performance of the bed and everything else. So now we can almost drill each section with 1 bit. We've achieved this, each section with 1 bit, no more. But in the 6-inch hole, sometimes we have to use 2 bits. So that means we drill close to half of the section and we pull out just to change the bit. But in the last well, we also overcome this issue. So like I said, PDC, we are using it for drilling. In track-on bits, sometimes we use for just cleaning the hole. Any run which is not drilling. Okay, drilling fluids. Like I said, drilling fluids is similar, and how they call it's the blood of the drilling life. Okay, and many times they put the entire rig in drilling life as human body life. You have mud pumps; they are doing exactly the same job as your heart, and you have mud; they are doing exactly the same job as your blood. So mud is really, really important while drilling to keep its properties as per the plan and to take care of the solid controls and the weight and rheology, viscosity, everything else is very, very important while drilling. So the functions of drilling fluids, one of them is well control. The well control means if you have any specific well while you are drilling, especially in the reservoir sections, you have trapped pressure in the formation, what they call pore pressure or formation pressure or pressure gradient, many names. If you drill, just ideally, just imagine if you drill that hole without having any fluid, any mud, then this pressure start coming into the hole, and then it's gonna start coming up to the surface. And this fluid and this pressure, trapped pressure, is mainly created by gas, okay? And the gas is, in majority of the wells, are sour gas. That means it's H2S. And if H2S gets to surface, it creates risk on everybody's life on that specific location and also in the surrounding area. So well control is prevented by the drilling fluids as the primary barrier. That means if you are drilling any development well or even appraisal well, you know your formation pressure in terms of PSI or whatsoever. And then on the other side, you have the hydrostatic pressure of the mud. Okay, so that mud will create downhole, will create a pressure called hydrostatic pressure, which is simply the mud weight multiplied by the vertical length of that depth and by any conversion factor. So that mud will overcome the formation pressure, and the formation pressure or the gas, the trapped gas, cannot escape from the formation into the hole and comes to surface. So that's how you prevent the gas coming to surface, and that's what they call the well control. If that happens, then you have to use the secondary barrier because you already lost your first barrier, which was the mud, and mainly the weight of the mud, because the only variable in here to increase the hydrostatic pressure is the mud weight, because the hydrostatic pressure is equal to mud weight times the vertical depth times the conversion factor. The conversion factor you cannot change. The depth you cannot change. It's what it is. The only thing you can change is the mud weight. But if for some reason you lose that barrier, then you are going to use the BOPs and other secondary barrier. So the first defense of line is the mud to avoid any well control. Another function of the drilling fluids is the hole stability. If you use inappropriate mud, your hole, especially in the shell section, can collapse on you. That means that the formation is just falling apart because you don't have a proper mud. So once the formation start collapsing, it's going to come on the bed and the stabilizers on the bigger equipment, and then that can cause a stuck pipe. And a stuck pipe is one of the nightmares while drilling any well. Another function of the drilling fluids, I'm pretty sure you've studied all this, especially for the students who are grade 3 and above, the hole cleaning. While you are drilling any hole, you are basically creating a lot of cuttings, right? You're crushing the rock, or you're grinding. If you're using the PDC bit, you're grinding the rocks. So what happens to this crushed or grinded rocks or particles? The mud is responsible to carry it and bring this back to surface. And also it transmits the horsepower and cool the bed. Of course, the mud, you pump from the surface, you have this normal temperature on the surface, it goes down, it cools down your downhole fluid, especially the bed, because when the bed you are applying a lot of weight and torque, and the rock, especially for some type of lithologies like anhydrite, for example, it's so hard, it's even harder than cement. So when the bed is hitting it, and then you are aggressive to get higher rate of penetration, you want to drill the well as soon as possible, then you are creating a lot of heat on the bed. So the mud can cool down the bed and the other components. Protect the formation. If you are drilling in your reservoir section, in the target section, for example, you have to use some materials that are non-reservoir friendly. That means they don't get along with the reservoir very well. If this kind of material goes into your reservoir, it will damage your hydrocarbons, and then as a result, you're gonna have a messed up data of the reservoir. So they can damage your reservoir. For example, we are using PHPA, but if you use the PHPA and then the PHPA while drilling the target section, the reservoir section, if it goes to the formation, then it can damage your formation. So, but the mud particles create a filter cake just around the hole. It creates a layer they call the filter cake. If you have a proper filter cake, the damaging or unfriendly reservoir material cannot go inside the formation. Even if they go there, it's not going to be a high amount. And also the formation evaluation. On any drilling site, you have a geologist, right? The geologist is mainly responsible to describe the cuttings that's coming back by the mud to surface. We also have the mud logging unit. The geologists go there and then they put the cuttings under microscope, and then they describe the cuttings, the shape, the size of the cuttings, and they tell the drilling people, this formation we are drilling, this formation we are drilling, we are getting to this, we are getting to this. So they keep updating the drilling people about changing the formation and all the alerts on all the specifications of the specific formation. And like I said, that's done by the mud. If you don't have the mud, there is nothing to carry the cuttings back to the surface. And also one of the functions of the drilling fluid is to transmit the data to surface. You have a lot of downhole tools. Most of the downhole tools are functioned by the mud. For example, one of them, and it's the key data you want to have, is the MWD data. The MWD, measuring well drilling, gives you which direction you are going to, and which inclination. So it gives you two things mainly. The azimuth, that means the direction, south, north, east, any direction, and also tells you how many degree you are penetrating to. So that's also transmitted by the mud, all those data to the MWD unit. Types of drilling fluids. It depends on the formations, and it depends on the oil company's policy. It depends on the area. It depends on the environment. There are many factors that you have to choose the most convenient mud for drilling any formation or any well. There are gas fluids or air fluids, or sometimes you just drill by air. In this case, you're using this kind of fluid if you have a low pressure reservoir. That means the formation pressure or the pore pressure that I talked about, which is trapped in the formation, is very low. You don't need any column of mud or liquid to overcome, to be overbalanced. You don't need that. Just air can do the job because it's already depleted formation or reservoir. So in this case, sometimes they use air. And the air could be dry, it could be gas, it could be mist, it could be foam, aerated mud. In my personal experience, we used to use this aerated mud in Mangesh area while we were drilling in that area. But for some other reasons, that wasn't successful. So nowadays, I cannot think of any oil company using the air or gas or foam or anything like that. Most of them, they just use the normal mud. Another type of mud or drilling fluid is the water-based fluids. This is the most common one while drilling. So in this case, on the top, as you know, gas or mist or foam or air don't have any viscosity. It don't have any rheology. So there is no way to carry or suspend the cuttings with this air. But with the water-based fluids, you can have a high gel, high yield point. And, as a result, you can stay away from getting stuck and some other issues. So this is one of the functions of the water-based mud. And also for the filtration control, like I said, for example, the filter cake, it can be created only by the water-based mud. It cannot be created by the air or gas. So in this case, this is another function of water-based mud. You can create a filter cake, and the filter cake, that layer doesn't let the damaged material go into the reservoir. And also, this is what we are doing, salts. In HKN, we are using a lot of KCl in our mud. A part of using KCl to raise the mud weight and stuff like that, it also gives us the shell, it prevents just the shell reactivity. With salts, NaCl or KCl, we add to the chemical mainly as shell inhibition, shell prevention. Salt can, with some reaction with the ions of the shell and stuff like that, the salt doesn't let any shell formation, most of the shell formations collapse on you. And also we have another type of oil-based mud, which is not very common. This one is, I would say, a bit rare. First of all, it's very costly. Can you imagine if you have the base of your fluid is water, you can get it from area, from the water well, from the pit, by tankers, and compare if you are using oil. It's way costly, oil-based mud. And plus, it's against environment. In many countries, especially the developing countries, there are a lot of environmental activists and stuff like that. They don't let you to use the oil-based mud. So that's why it's a bit rare. It's very costly. It's very reservoir unfriendly. But you can use, if you cannot overcome your shell sections by just the water-based mud, then you have no choice but think of using the oil-based fluids. And also, it has a lot of functions like reducing the torque. If you are using the oil-based fluids, obviously it has more lubricity, the oil, compared to water. So your torque is going to be much less. In my experience, we have drilled through some sections that the torque was on the limit. It was so high to rotate those string has a limit for the torque. If you pass that, or if you exceed that, you're going to break your string. So if you have no choice, you have to pump some lube, diesel. We have also pumped diesel or some lube just to reduce the torque by increasing the lubricity. And then mud weight, again, is one of the drilling engineers' job to select the best mud weight. Everybody can think and everybody can ask that question. You have a very wide range of mud weight. What's if your mud weight, just imagine if only water is 8.33 ppg. With some other material, you cannot have any mud weight less than 8.5. And also you can have mud weight up to 20 ppg, okay? So from 8.5 to 20, it's a very wide range. But what value would you pick up to drill a section? So in here, you have a window, what they call a window. You have a limit you cannot exceed, and you have another limit you cannot be below. The pore gradient or the pore pressure, as we discussed, if I use 8.5 ppg mud weight, if I multiply this by the depth and the conversion factor, is that going to be overbalanced? I.e., is that going to be bigger than the formation pressure, and then I'm going to stay away from well control? That's the criteria. It has to be more than, when you multiply the mud weight by the depth and the conversion factor, it has to be more than the formation or the pore gradient or the pore pressure. If it's less, that means you're underbalancing and you're going to get a kick, and it can be a blowout later on. So that's a no way. You cannot be below, you see the mouse cursor, you cannot be below this. And on the other hand, you have the upper limit, which is the fracture gradient. For many wells, especially development appraisal well, you know. And for that, we are doing a test they call LOT or FIT. We don't need to go into that detail, but you know, in most cases, you know what's your maximum limit for the fracture gradient and what's your minimum limit. So your mud weight should be in that window. Okay, so that's how you pick up any mud weight. The well control. The well control, like I said, if you have a proper mud, then it's very unlikely you get any kick, any well control issue. But for any reason, if you lose the ability to prevent the kick or the gas coming into the hole by the mud, if that happens, you cannot prevent it from the mud. If that happens, it comes to your hole, you have no choice. It's going to come to surface, but you have to close this, what we call BOP, blowout preventers. Okay, so the BOPs, remember this, are the secondary barrier, the secondary defensive line. If your mud is not sufficient to control the gas, the trapped gas, or the formation pressure, that means the gas is coming into the hole and then to the surface, then you have to use the secondary barrier, which is the BOPs. Okay, the BOP functions contain the pressure, and then it connects to the wellhead, as you see, if you see my mouse. And then also you can change the pressure rating for any equipment from lower to higher, higher to lower by changing the flange. So this is the function of the BOP. The BOP stack, as you see in here, we have various rams. We have pipe rams, shear rams, blind rams, and then on the top we have annular preventer, and then you have the flow line, which is the mud is passing through this flow line back to the mud tanks. And all this equipment, they are hydraulically operated. You need to apply hydraulic pressure, and that's done by what they call CUMI unit. Okay, CUMI unit is a big unit with the stores of hydraulics, and you can close all these because it needs a lot of pressure and force to close all these massive equipment. The pipe rams, you can use the pipe ram is basically one of the BOP components. You can use the pipe rams only around a specific pipe size. For example, if this is a 5 pipe ram, for example, you can close your well if you have a gas, or shut in your well only around the 5-inch OD, nothing else. You cannot close the pipe ram around the different sizes of ODs. The shear rams, this is worldwide is very rare to be used, because the shear rams, if you have for some reason, you have to cut your pipe. So that means you drop the entire string with the BHA and everything, all those super expensive tools into the hole. So if you use the shear rams, even if you shut the well in and eventually you kill the well, you get rid of any catastrophic accident, but later on you have to deal with fishing because you have cut the pipe and everything is in the hole, and that operation is called fishing. You need to get everything back. And shear rams nowadays are combined with the blind rams. That means as you close the pipe, you cut the pipe, you shear, and then at the same time you can also seal it. Annular preventer is doing exactly the same job as pipe rams. The only difference is you can close the annular preventer around different sizes of ODs and different shapes of ODs. The reason we have the annular preventer, why not just a backup of the pipe ram or another pipe ram, is because especially when you get to the BHA, you have stabilizer, which is a irregular shape. It's not a regular shape. It doesn't even have. Yes, I can hear you.
Yeah, have remained. So
okay. In 2 minutes, I'll get everything done, and then I'm gonna take the questions. Okay. Okay. So the annular preventers are just doing the same job as the pipe rams, but it can shut the well in around different size, different ODs, in different shape. Okay, preventing the blowout. Like I said, if your mud is not sufficient to control the gas, then you have to close one of those equipments based on what you have in the hole. Okay, these are the scenarios. Some scenarios which you might face while drilling, but we can discuss this anytime if there's a question about any kind of problems. So
thank you, Kakim.
Okay.
How many slides have remained?
Probably 3.
Okay. Continue.
Okay. The rig site, the organization on the rig site is, just very briefly, you have a top guy who is responsible over all the operation from the oil company like HKN, who's called drilling supervisor, or in the industry they call company man. Okay, and then below company man you have the rig, and the rig personnel as the tool pusher, and then the night tool pusher and the other. So basically you have any operator company like HKN, and then below you have the rig, and then on the other line you have the service companies who are doing cement job, wireline, and some other stuff. Drilling with the mud motors, this is the mud motor. Very basic idea about the mud motor is, while you are pumping, the motor has a stator and rotor. It can rotate the bit without applying any rotation on the top. Okay, so directional drilling, we're gonna discuss this slide in detail on the third day. So now I can take all the questions. We have only 2 slides, but directional drilling slides are gonna be on the third day. So no big deal if we skip them now. Please ask the questions.
Thank you, Kakim, for this informative seminar. Dear participants, if you have any question, you can ask, but please just specify your questions. And Kakim, you also please shorten your answers.
Okay.
So who has any question?
Yes, I have one question.
Yeah.
Thanks a lot for this great seminar. My question is about drilling fluid. We know as we make drilling fluid, the pH of drilling fluid should be more than 7. So Why is that?
Okay, so basically all the drilling fluids must be alkaline. So that means you cannot be below 7. You have to be above 7.
Yeah,
For
but
the
why?
okay, if you have any, for example, if after drilling any cement, if you don't have any pH above 7, your cement can react and then they can deteriorate, and then it can create problem in collapsing the hole, and then in the end you can be stuck in the hole. That's one of the reasons. And the other reasons also for formation reactivity. All the pHs can, for example, the KCl and some other pH material can react with the formations in a better way than the any pH less than 7.
Thank you, Kemen. Any other question?
Okay, Kemen. Just I have a question from the first part. It's remain in my mind, so I just ask about it. You said about the rotary system, and you said we have the Kelly, and also we have the top drive, and also the third one is the motor, downhole motor that is used for the drilling hole. So, what's the vector the company depended to choose one from this system, or the company used all of these together?
Okay. The Kelly, like I said, it's less efficient compared to the top drive. Nowadays, Kelly is very rarely used, and usually it's used for the shallow wells. Like in Kurdistan, as far as I know, they use in Kargru because the wells are shallow. The top drive, you can rotate from the top anytime. If you have any hole problem, you can rotate. You can back rim. That means you can, while you are pulling, you can back rim. That's first. Secondly, you can drill a full stand with the top drive. This is main thing is the top drive over the Kelly system. And it takes less time to make connection and use the top drive, way less than the Kelly. And regarding the motor, for example, in our operation, we use the mud motor to create more RPM on the bit, because you have the RPM, which is applied by the top drive on surface, and then you have another rotation, which is created by the mud motor on the bit. So you have a total of RPM, the surface plus the downhole, which is created by the motor. So the more RPM, the more ROP, the more meterage you can drill in an hour. So that's why we are using the motor or the top drive.
Thank you.
Okay.
Any other question?
Okay, sir. Hey, how are you? Hey, sir.
Please,
I
okay,
have a,
bro. Yeah, bro. You can ask.
okay. Thank you for your presenting. Actually, you may mention some problems during drilling, but I want to know the most common problems that we face while drilling.
Okay, so that question was asked also in the first part, but I'm gonna go through them again. I'm just talking. Yes.
I think we have planned to answer those questions in another day. For example, in drilling fluid, we may speak about drilling problems. So let's just let this question to that day. Another
Okay,
question.
thank you.
Okay.
Mr.
Let's
Hammond?
take another question then. Yes.
Yeah, I've got a question here.
Guy Karish, yeah, you can ask.
No.
Yes.
Yeah. We already know that the hydraulic pressure is used to control the formation pressure of the wellbore by maintaining the two pressures together. But how do we measure the formation pressure under the ground in order to use a convenient pressure against it? Are there some software programs or some sort of tools are used? I just need you to give me the names of some of these that are used for measuring the formation pressure.
Okay. For the exploration wells, you have the gradient of water, right? So in the exploration wells, that's a nice question, basically. If you go to drill any wildcat well, you don't have any idea about the formation pressure. So you are using the water gradient. You just imagine that depth multiplied by the water gradient, and then that tells you this is your formation pressure. This is for the exploration wells. But for the development wells, you can know that with the wireline, some wireline tools. Before that, the seismic will give you a rough idea, and the wireline tool, and sometimes with the some other tools, the logging tools, you also know that. But if you have a development well, that means you already have some other wells, the offset wells, which are producing hydrocarbons. So if you are producing the hydrocarbons, what's bringing the oil to surface? The formation pressure. And then you know how much pressure is downhole. So that's how you know the formation pressure.
So, sir, you're saying that this is more connected with the well logging than the software programs, right?
With the software program is the IT part of the issue. But how we know if it's exploration well or the first well you drill, you imagine the water gradient, the water pressure by the feet, which is 0.465 or 56 times the
less than 1 minute.
Yeah. Thank you very much.
Thank you. And finally, I just want to read a comment here. Mahasami has added extra information. He is saying that DNO uses a small rig called servicing the rig, which is a killer-based system either for drilling shallow wells or workover wells. Thank you, Mahasami, for this extra information. So thank you very much